Let's determine the enthalpy change when hydrogen peroxide decomposes into water and oxygen. We need to find the enthalpy change for the decomposition of 2 moles of hydrogen peroxide into water and oxygen gas. First, let's understand what we're trying to find. Our target equation is the decomposition of liquid hydrogen peroxide into liquid water and oxygen gas. We'll use Hess's law to find the enthalpy change for this reaction. We're given the standard formation enthalpies for the compounds involved. The standard enthalpy of formation for liquid hydrogen peroxide is negative 187.8 kilojoules per mole. The standard enthalpy of formation for liquid water is negative 285.8 kilojoules per mole. The standard enthalpy of formation for oxygen gas is 0, as it's an element in its standard state. Now let's apply Hess's law to solve this problem. Hess's law states that the enthalpy change of reaction equals the sum of enthalpies of formation of products minus the sum for reactants. We construct a thermochemical cycle using the formation reactions of each compound. Let's draw the Hess cycle to visualize the energy pathway. Here's our Hess cycle. The top arrow shows the direct route we want. The bottom path goes through the elements in their standard states. Now let's apply the cycle to calculate the enthalpy change. Route 1 is the direct path from reactants to products, which is what we're trying to find. This is our unknown enthalpy change of reaction. Route 2 goes through the elements by first decomposing the reactants, then forming the products. Route 2 equals negative 2 times the formation enthalpy of hydrogen peroxide, plus 2 times the formation enthalpy of water, plus the formation enthalpy of oxygen. By Hess's law, both routes must give the same total enthalpy change. Now let's substitute the values and calculate. Rearranging, the enthalpy of reaction equals 2 times the formation enthalpy of water plus the formation enthalpy of oxygen minus 2 times the formation enthalpy of hydrogen peroxide. Substituting our values. 2 times negative 285.8 plus 0 minus 2 times negative 187.8. This gives us negative 571.6 minus negative 375.6, which simplifies to negative 571.6 plus 375.6. Our final answer is negative 196.0 kilojoules. Let's interpret what this negative value means. The negative enthalpy change of 196.0 kilojoules means this reaction is exothermic and releases energy. Energy is released when hydrogen peroxide breaks down into water and oxygen. This energy diagram shows that the products have lower energy than the reactants, with 196 kilojoules released during the reaction. Let's summarize what we've learned. For the decomposition of hydrogen peroxide into water and oxygen, the enthalpy change is negative 196.0 kilojoules. We used Hess's law with standard formation enthalpies to calculate this value. The negative value confirms this decomposition is exothermic and releases energy to the surroundings.